is for section 1.1a, which is sampling and parameters. And before we get started, I just wanted to mention two things. One, with any of these videos, you are welcome to write the notes on your own separate piece of paper, or you can print the file that I have in Canvas and write it on there, or you can put it in your tablet and just take notes on your computer, however works best for you. To me, the worst method is just writing them on a separate piece of paper, only because it makes it harder to reference when you have a quiz or a test to go back. And if you just have a pile of answers, then it doesn't always make sense when you're trying to use those definitions for notes. So really, it's up to you as long as you are watching and following along. Okay, number two is, I just got a new pen for my tablet and I haven't written on this one before. So these first few videos are probably going to be a mess, but I'll get the hang of it and my writing will get better. I have confidence. Okay, so here is the worksheet and we are talking about sampling and parameters. And so let's start off with a few definitions. So number one, a population. So a population is the whole group. It's everything that we are talking about. So if you are wanting to know how people are voting on the upcoming election for the president, then the population would be the whole United States, every single person in the United States. But if you were wanting to know about how people were voting for governor, well, then that's more localized. So that population would just be everybody in that state. So the population is not always everyone in the US, it's just everyone in whatever group we're talking about. A sample is a subset or smaller portion of the population. And the sample is the people that we're actually going to interview or get input from, or they're going to take the poll. The sample is much smaller, and that's who we're talking to. Data is what we get when the population is sampled, or data is going to come up a lot more in chapter 2, but you might just hear data mentioned. But more moving on to what this section is about, parameter. So a parameter is a number, I'm supposed to say about, a number about the whole population. So you'll notice that population and parameter both start with P. P words go together. So the population or the parameter is a number about the population. So if we were talking about, we want to find the average shoe size of everyone in America, then the parameter would be that actual average shoe size of everyone in America. The statistic goes along with that, but the statistic is the number describing the sample. So using that same example, if we were talking about the average shoe size of everyone in America, we're not asking everyone in America. Our sample would be the, 50 people that we ask, and the statistic would be the average shoe size of that sample. So sample and statistic go together. They both start with S. Population and parameter go together. They both start with P. Parameter and statistic are both those numbers describing either the whole population or the sample. Okay, so let's look at an actual example instead of me just making something up in my head. And it says, you want to find the average test score of the students in every math class in 11th grade. There are 15 math classes in 11th grade. You survey the scores of 7 math classes. You calculate the average test score is 83%. Find the following. So with population, since it's talking about the whole group, we typically start with the word all. And if you see the word all, then you know you are in the population. So for this, we're talking about students in 11th grade math. So we want all students in 11th grade math. The sample is just going to be the chunk of people that we interview or talk to determine this, because we're not going to be surveying all the students. That's too many. So the sample is going to be just who we talked to. So we talked to the 7 math classes. So we're going to say the students, oops, trying my new pen with my eraser. That was cute. All right, so the students in the 7 math classes surveyed. So all the students in the 11th grade math are the population, just the students in those 7 math classes that we surveyed, that's our sample. Notice it's not, the population is not all the students at the school, because I'm not wanting to find the average test score of all the students at the school, just the average test score of those 11th grade math classes. Okay, so then the parameter is going to go with the population, and these two, making too many little loops over here. All right, these two right here, parameter and statistic, these are both numbers about whatever they go with. So parameter is a number about the population, and statistic is a number about the sample. Okay, so we are doing parameter, which goes with population. And so what number describes, or are we looking for about all the students? Well, we're trying to calculate the average test score. That's what we're looking at throughout this problem. So the parameter is going to be the average test score of, and it's almost exactly, let me highlight this. It's almost exactly this right here. It's the average test score of all the students in math class in 11th grade. All students in 11th, we'll just kind of abbreviate 11th grade math. So it's not the number of students, it's not all the students, it's something that describes those students, and what describes them is their average test score. We don't know what it is, it's not given in here, but in words, it's the average test score. And so then the statistic is going to be the average test score of the sample, and we know that. We know that the statistic is 83%. The statistic is going with the sample, and it's a number, so it is 83%. And then I'm going to put it in words just because this is the notes, and I want you to have all the information right here. On the homework, it would say like 83% would be the answer, but just in case you forget where that comes from, that's the average test score. That's the number of, and I'm just going to say sample. Just to write a little faster because I'm writing a lot here. It's the statistic is at 83%, which is the average test score of only those 7 math classes. So we can't say that the parameter is 83% because the parameter would be the average test score of all the classes. However, we only calculated the average test score of the sample, or of the 7 classes. Okay, you're going to find that chapter 1 is like super vocab heavy. So make sure you are keeping these definitions handy when you are doing your homework. Next up, the different kinds of sampling. So here are 4 different kinds. It's not the only 4, but it's just 4 that are talked about a lot. And so number 1 is terrible. It's just listed because people do it. And so the first one is convenience sampling. And convenience sampling is just something you do out of convenience. So for example, you stand outside the grocery store and you ask people a survey question, or you stand in the middle of the quad at school and ask people, whoever passes you by, ask them a question. That's not a good way of sampling. We'll talk about bias more later. But the reason that's not good is because you're only getting the people that pass by you at that moment that even want to talk to you. So it's not really a good sample of the whole group of whatever you're looking at, unless what you're looking at is people who walk out of the grocery store at the exact time that you're there. So that's typically not what it is. So it's just out of convenience. It's not really a great way of sampling. The other 3 are a good way of sampling. So let's look at the first one. Systematic is the easiest one to find, to figure out in a problem, because we systematically take things. And so usually what that looks like is like every nth person. And so what I mean by that is if you want to interview, if you want to find out how long it took people to travel to a football game, you could stand at the ticket entrance, and then you don't want to ask every person who comes to the football game. That would take forever. But you would have a partner, and the partner would say, okay, let's start with person number 7, and let's take every 10th person after that. So we'll take the 7th person, we'll take the 17th person, we'll take the 27th person, and so forth. So you're counting by tens. I put every nth because it doesn't have to be by tens. It could be every 100th person. It could be every 50th person. But it's some sort of like systematic order to things to start counting. So you start at a random person. So it says you pick a starting point at random, and from there you count systematically and take whatever number that is. So it's easy to find in the problem because the problem will say something like, you counted every 75th person. You see that TH word in there? You're like, boom, systematic sampling. The harder two, cluster and stratified, because they both put things in groups. And so for cluster, it says you split the population into clusters that are chosen at random. So let me try to squeeze this in over here. Say we have a school. It's gonna be the world's smallest school because I'm trying to squeeze it in over here. Here's a map of the school, and here's the classrooms. Classroom 1, 2, 3, 4, 5, and 6. So people are in class right now. And so to do systematic sampling, you would take everybody cluster, everybody in room 1 and like everybody in room 5, and that would be the cluster sampling. So they're split into groups just however, and then the group is chosen by random, and you do all the objects in the group. Stratified sampling is a little different because we are going to split people up. So this was kind of like who was in classroom 1 at that time. It's just whoever was already there. Stratified, we're going to split the people up. So let's say we split people up. I'm going to just say we're at a high school and we put all the 9th graders in this group and all the 10th graders and all the 11th graders and all the 12th graders. The reason I have them split by that is because it's impossible for anybody to be overlapping. Nobody is in 9th grade and 10th grade at the same time. So I can just take whoever you give me, I can split them up into groups, knowing that there'll be no overlapping. I don't want to say something where they could overlap, like, okay, let's split into groups of your favorite color, because some people are like, well, I have 2 favorite colors and they don't know what group to put in. Or even like at college, what's your major? Well, some people have a double major, so they don't split evenly into group, or they don't split into one obvious group. This way they split into one obvious group. Okay, so then what I would do, now that I have everybody split up, I'm going to take, let's just say, these 5 people and these 5 people and these 5 people and these 5 people. So I split people up based off of some characteristic, their ethnicity, location, age, in this example, grade, and then I pick a few people from every group. So cluster up above was a few groups, pick everybody. Stratified was pick every group, but just a few people out of each group. Yay. Okay, so these are the 2 that are definitely most complicated. So I put them in these 2 examples below to figure out which one's cluster and which one is stratified. So, eek, zoom too much. Okay. So it says Annie wants to estimate the average number of AP classes a student at her high school takes. She decides to randomly select 6 classes and uses all the students in those 6 classes to estimate. Okay, so she randomly selected 6 and used all the students in those 6. Now, we don't know how many AP classes her school has. You might be thinking, oh, my school, we only had 5 to begin with. So 6 sounds like a lot. But it sounds like since she selected 6 of them, it sounds like there was more than 6 to begin with. And then specifically because she used all of the students in those groups, then this is going to be cluster because we have she randomly picked groups and then everybody in that group was chosen. On the second one, it says Sarah wants to inspect the cleanliness of the rooms in a hotel. There are 10 floors in the hotel. Each floor has 20 rooms. From each floor, she randomly selects 2 rooms. So she chose from each group, and from each group, she selected a couple. Just in this case, it's 2. In my example, is 5. It could be 50, just not all of them. We know that there's 20 rooms on each floor, and she chose 2. So she chose 2 rooms from each floor. This one is stratified. So you're looking at, did she choose all the groups or did she choose some of the groups? Did they choose everyone from the group or did they choose a few people from each group? That's how you differentiate between cluster and stratified. Okay, yay, more vocabulary. Don't worry, chapter 1 is going to have a ton more vocabulary. So you definitely want to have all of these vocabulary words handy when you're doing your homework and when you are doing your tests and quiz. Okay, now you'll notice that this says section 1.1b. Oops, hang on just a second. Okay, sorry if there's a weird blip in there. I had to pause it real quick while I answered a phone call from my son. Okay, so here we have section 1.1b. Now, with the split, the first one, everything we've already talked about, that's one homework assignment. So that page will be for the first homework assignment. And then now this one, this is 1.1b. This will be the second homework assignment. It's just all in one video because it's only 2 pages long. And so you'll notice every time there's a new headline or a heading in red, that will correspond with a homework assignment. Okay, few more things, and then I think we're about done. Okay, perfect. So it says, to obtain useful results, a scientific approach should be followed. This basic approach can be summarized in a few steps. And what that really means is this class can be summarized in these few steps. This is kind of what we are going to be doing throughout the whole class. So write a question that can be answered by collecting data, determine what variables to measure and how to collect the sample, analyze the data and create appropriate summaries. That's going to be most of the middle class, and then create a report of the results, draw conclusions and whatnot. That will be the last third of the class. So right now we're just talking about what collecting data looks like and what are good ways to measure and collect a sample. And one thing that it is important to know is the sample must be representative of the population. So however the sample is chosen, it must represent the population. And I'll tell you why as soon as I spell this word, population. Okay, so what that means is if you want to know who people are voting for governor, you don't need to ask everyone in, let's say you want to know who they're voting for governor of California. You don't need to ask everyone in California. You can ask a sample of people in California who they're voting for. But it would not make sense to ask a sample of people in Michigan who they're voting for governor when you're trying to find out about California, because people in Michigan can't vote in California. So in that example, the sample does not represent the population, so that would be not a good design study for that question. And so that's kind of what we're looking at in this first question. It says a statistics student is doing a project for her class. She wants to make a prediction for the outcome of the upcoming national election. Since there are only 2 candidates, she decides that her question is, which candidate do more people favor in the upcoming election? She decides to randomly interview 100 students crossing the courtyard, so that's her sample right there, about the preference is this sample good for drawing conclusions about the results of the election? Okay, so in this example, since we're talking about an upcoming national election, that tells us that the population is going to be all U.S. All U.S. citizens who can vote. So we don't want to include people under 18. We don't want to include people who can't vote. Now, we can include people who don't vote. That's different, but we're looking at who can vote. That's who is relevant in this question about the national election. And it's everyone in the US. This is national, so it's not just one state. And she interviewed 100 students crossing the courtyard. So right here, that's our sample. Is the sample good for drawing conclusions about the results of the general election? No. Oopsies. There's a button on here that erases, and I just like typing and erasing at the same time. All right. No, it doesn't represent the population. I will tell you why. Represent population. Okay, so 100 students crossing the courtyard. Well, we don't know anything about these students. If you're talking about a high school students, most of them are not even 18. If you're talking about college students, some of them are not even 18. So not everyone crossing the courtyard can vote. The other issue with this, aside from the fact that they're not necessarily old enough, let's just say that everyone's old enough for whatever reason, these are all 18 and up. The other problem is it's 100 students crossing the courtyard at that time at that school. Where's the school? Chances are that people at that school have maybe similar views. That doesn't mean they're all voting exactly the same, but they all have something in common. Even if all they have in common is they all live in this city or they all go to this college, that does not represent the whole population because the whole population does not go to that college. The whole population does not live in that city. And so we are missing a lot of different types of people throughout the United States by only interviewing those 100 students. And so for a sample to represent a population, they pretty much want to have nothing in common other than like their people. They're people that represent the people, like, so for example, this population, they're people that are US citizens who can vote. That's the only thing that they can have in common is the population. Other than that, we want to have people of different ethnicities, different genders, different hair color, different backgrounds, different socioeconomic statuses, different ages, different everything you can think of. We want to have them different. And if we just have 100 students walking across the courtyard, they have too many things in common. They're all about the same age. They all live in about the same area. Like there's just too much in common. So that is why it doesn't represent the population. Okay. Last but not least, more vocabulary. So here, these are some big words and they're going to come back throughout the semester. These are probably the only words that come up a lot throughout this course. And that would be observational and experimental. And this describes two types of studies. So an observational study, you don't do anything to the people. You make no attempt to control any aspect of the individuals in this sample. So for example, it says it's typically used when it's difficult, unethical, or impossible to control the factors in the sample. So for example, if we were doing a study on smokers, we are never going to take 100 people and say these 50 people are not going to smoke and these 50 people have to smoke cigarettes. Like that's not, we're not going to do that. If we have a question about smokers, we are going to observe people who already smoke to make those, to make conclusions about the study. In an experimental study, that is where we take them into groups and we say this group does this and this group does that. And then we figure out what the results are based off that. We as the researcher would control it. So for example, this group is going to run for 30 minutes a day. and this group is going to walk for 30 minutes a day. And we're going to see what their resting heart rate is at the end of the month, or, something like that. That is not unethical for people to sign up and you to assign people to jog or walk or whatnot. It is unethical when you start introducing like drugs, alcohol, cigarettes, that kind of stuff. That would be an observational study. Also, well, let's just look at these examples. Sometimes I just make up examples off my head and it gets more random. Okay, so we have a large manufacturing firm interested in the effect of the temperature of the manufacturing floor for worker productivity. Over the course of a year, the firm randomly samples its 103 sites and records the temperature and the quantity of items produced on that day. And so this is another thing. I really focus on the unethical part, but this is another thing is you can't always control the other thing that's going on. That would be another example of observational. So for in this example, they can't control if it's a hot day, a cold day, a sunny day, a snowy day. They can't control that, but they want to know if that temperature will affect the people, the 103 sites, and if it affects the quantity of the items. And so this one right here is an observational study. Okay, the other thing is experimental studies are typically cause and effect. And so, well, never mind. I'll explain it on this one. Okay. Biology student is interested in the relationship between temperature and germination time for soybeans. So they get sample seeds from multiple sources and randomly selects 180 seeds from them. And he sets up 3 growing stations. One's at 20 degrees Celsius, one at 15, and one at 25. He divides the seeds into 3 groups of 60, and he plants the seeds from at each temperature, and records the germination time. Is this observational or experiment? So this is an experiment because he controlled what happened to each group, and he specifically set up the temperatures. He divided them evenly and put an even number in each group and decided to see what was happening. This has, since it's an experiment, it has a controlled factor, and the controlled factor is the temperature in this example. Now, I just want to go back to the last example. That one also had temperature, but they didn't control the temperature. They just wanted to know if that temperature affected the productivity. So they recorded the temperature, but they never had any influence over the temperature. In this one, he very specifically set the temperature for the 3 groups. And so that's what made it an experiment. Because he controlled the temperature, that's the control factor. He can't control the germination time. So that would be like the effect. The cause is the temperature. The effect is the germination time. All right, well, that was more talking than I meant to do in the first video, but here we are. I'm probably not going to be talking any less, so yay. All right, that is it. Email me through Canvas if you have any questions. Bye.